جي 3 4 1 صح؟ ماينس 3 1 على 4 اللي جيت هنا ماينس 3 1 على 4 مفيش. بعدين نزيد نكمل ماينس 15 على 4 ماينس 2 على 4 جي ماينس 15 على 4. how to write ماينس 15 على 4 4 و 3 و 3 ماينس 3 3 على 4 صح؟ بعدين ماينس 15 على 4 ماينس 2 على 4 يساوي كم؟ ماينس 17 على 4 جي 4 4 1 هاي. Is this the correct answer? Why did we remove it? هنا remove every time صح؟ what he did هنا 15 على 4 بعدين صار 12 على 4 9 على 4 6 على 4 3 على 4 9 3 على 4 minus 6 على 4 صح. it's same what doing هاي 6 على 4 هاي minus 6 على 4 بعدين minus 5 minus 8 على 4 هذه how to write. so 15 على 4 حولها عن prob 3 بعدين صارت 9 على 4 صح؟ minus 2 على 4 يساوي كم؟ كم جي؟ every time I'm doing minus 3 على 4 كم جي؟ 6 على 4 minus 3 على 4 جي كم على؟
2 على 4
لا 3 على 4 minus 3 على 4 جي كم؟ 0 بعدين minus 3 على 4 بعدين minus 6 على 4 بعدين نعاودوا من هنا جي minus 9 على 4 بعدين minus 12 على 4 زيدها minus 3 على 4 جي minus 15 على 4 minus 18 every time you are doing صح minus 20 4 على 4 لا 21 هذا مش 20 24 21 every time 3 صح understood repeat again هذه كم جي
3 على 4
15 على 4 حولها الميكسد تاني 3 بعدين 9 على 4 do minus do ترى every time do minus 3 على 4 هنا من هنا 9 minus 3 6 يا 6 على 4 minus 3 على 4 هنا اكتب هنا minus 3 كم تصير 3 على 4
Hey, what is 6 3 9
3 وات
4
Hey.
3
3 على 4 minus 3 على 4 يساوي كم؟
negative 3 0
0 minus 3 على 4 equal
negative 3
على 4 don't forget 4 زيدها تو
negative 6
صح على 4
negative 9
صح
negative
زيدها 3 9 minus 9 minus 3 minus 12
12
ها
15
صح 18 يعني قاعد تمشي بعدين minus 21
29
لا كيفاش 21 3 4 5 25
no one here
انت هيكتب 25 تصير minus 28 مفيش 28
30
لا بس ب 3 20
negative
every time you are doing 3
28 29 30 31 ها
حطيت هنا 24 21 بعدين 24 27 30 33 هنا 27 30 33 بس 33 على 4 لما تعملها 33 على 4 يساوي كم؟ 8 32 و 1 يعني 4 multiply by 8 plus 1 جي كده هاي 24 plus 3 is 27 هاي 2 multiply by 1 2 plus 1 3 على 4 هاي 3 على 4 صح؟ عشان كده هذوما التانيين
ألو؟
مش موجودين.
equilibrium a dynamic equilibrium only achieved in a closed system.
وين الدرس تبع الكيليبرام؟
ما عنديش هذه بس بعتت.
لا موجود. احل الاوراق اللي عندي موجود. ما ما يسمش كل شيء بعته في النوت. هذوما التمارين بس وين الدرس؟
تمارين دي حتى زادة تمارين هذيك الدرس.
ده حل الدروس فتلقى المثال.
reactivity metaseries periodic table
هذه اورجانيك كيمستري.
bonding sometimes with equal charge law. Let's see.
هاي من هاي من
اوكي.
هاي الديناميك. هاي الديناميك. هاي هنا. هاي الكيلوغرام. شفتها؟ بقى اجي جيب الامتحانات وحدهم حطهم في بيبر اجي نقول نقلب النظام. اوتي ويجون يونيفرسيتي اجي اسيد بيس اتوميك ستراكشر. هذه اول درس قرأته لكم. كيميكال كالكوليشن هيك قراته. بارتيكل اوف ذا ماتر. اليوم مش قريتهم الكيلوغرام. هذوما الكل حطهم هنا. هات الاكزامز. هذا الورقه دي مهمه في الترتيب. هاي الكيميكال رياكشنز اللي قرأتها لكم هذه كل it was done. bonding
periodic table
periodic time
reaction
reactivity also قرأتها. شفتها مان مش نزبلوا. هذوما الامتحانات. هاي عشان لما تطلب امتحان تلقاه جاهز. شد هذوما الاكزامز. هذوما الدروس. تقولي ما عنديش. she give us this to do it. درس مش تقريكم اليوم درس
equilibrium.
بقية الدروس هنا. شد وركز معاها واكتب. خلاص يا لا. حط هذه في الجبال.
اوكي.
Hi Minna. Hi Aman Allah. Hi girls. Hi Adham. Everybody is good? Hello? You hear me Minna? Aman? Okay. We will talk about important chapter today. It is grade 9 syllabus. It is related to kinetic or energetics. We finished already a rate of reaction. Okay, we finished a rate of reaction and we finished calculation of the energy change. And that is the last part regarding the energy. So it is one unit talking about the energy. And we'll practice today another kind of question from a chemical calculation. I promise that every class we do one question about the calculation. All right, let's see what we have to do about this chapter. Pay attention, please. The first page here is talking about equilibrium. Equilibrium. Let's see what is this equilibrium. That is the chapter. To finish, it's reversible reaction or equilibrium. The chapter, it is after heat of reaction, if you arrange in the order. All right? So, I start to talk about a normal reaction. The normal reaction. We talk about if we have particle A colloid with particle B to form what? One full-headed arrow to get product. To get product. Equilibrium. Okay? So once we see this arrow, we said a reaction finish when? When the reactant get used up. What's the meaning used up? Finish. No more. No more. This most of the reaction this way. We get new product when the reactant colloid hit each other. All right? Now, I have this sign today. What is this sign? Yalla ya Adam. Reversible reaction. Reversible reaction. So, first question we see regarding this chapter, what is the meaning of this sign? 1 or 2 marks. Write down if you like to write down any note for yourself, any point it may be questioned in your final exam.
9 على 5 plus 2 على 5 جي 11 على 5 plus 2 على 5 جي 13 على 5 اوكي؟
Yes.
نحولها
Structural methods.
انتوا عندكم كويز بكره؟
9 على 5 جي 5
ما قلتش ليه قبل ما تشتري مني. Okay, I have this one. What can I do? I already sent homework about the extraction. Solve and send to me. I correct. Okay.
Miss, is there a definite due date or we just send it before the Monday?
5 multiplied by
Okay, let's see. Let's see what can I do. All right, so we get back again. If you see this sign and they ask, what is this sign?
2
Reversible reaction. What is this reversible reaction? A reacted with B to form a product, but once a small amount of the product formed, it breaks down to get a reactant again.
9 divided على 5
This is very bad because our goal to get a product. All right, I need my product, not to stay here with the reactant in the equation. All right,
كم؟
so we get another important point. It's called a definition for minimum 2 to 3 marks in your exam. Dynamic equilibrium. It's called dynamic equilibrium.
13
What
على
is the meaning of dynamic
13
equilibrium?
divided على 8 1
First point, in this reaction, everything is written in the note, but if you want to write down in your own way, write down. Okay? In dynamic equilibrium, this reaction occurs in a closed container. That's the first point. So mandatory, it occurs in a closed container. I have a container which is closed, so that's the first point. Anyone understand the meaning of dynamic? Dynamic. What is the meaning of dynamic?
Dynamic is
Movement. Movement. What is the meaning of that? We will understand in a few seconds. So, for example, if we reach something called equilibrium. They will ask, what is the meaning of equilibrium or dynamic equilibrium? So first point, a reaction never stop. Never stop. The meaning of dynamic. So the reaction never stop. We called about the first kind of reaction when we see one full-headed arrow. A reaction can stop when the reactant used up, no more. But in this kind of reaction, if you see these two arrows, a reaction never stops. Never. It will go from left to right and from right to left all the time. Exactly like what? Like a train going from Abu Dhabi to Dubai, and then another train from Dubai to Abu Dhabi. Still going all the time, never stop. All right? And they found that in equilibrium, a rate of forward reaction, what is this forward? A forward formation of the product. A rate of forward reaction equal a rate of backward reaction. Exactly, if I explain using this example, if we have two trains, this train is going with the same speed of this one. All right? Or, for example, Helia is writing a text and Layla is rubbing the text with the same speed. All right? So let's revise this part again. And what is the question? A definition of dynamic equilibrium. So first point, reaction never stops. And it occurs always in a closed container. In addition, a rate of forward equal a rate of backward. Don't say this reaction equal a reaction. No, a rate of this direction equal a rate of the opposite direction. Last point, a concentration of either a reactant or a product stays constant, stays unchanged. All right, that is the number 4. Let's see what I have here in the note, where I will give example, will explain in factors. So First point, I wrote it here in the title of the chapter. It occurs in a closed container, first point. And the dynamic equilibrium, that is the most important definition in this box. It is what? A rate of forward reaction equal a rate of backward reaction, all right? And what else? Concentration of either reactant and the product stays constant. These 2 points in this box, important. Minimum 2 to 3 marks in paper 4 or 1 mark in paper 2, all right? So this definition in this box, important. Clear?
Yes.
Yeah.
The equilibrium in how like
Yeah.
it's different.
What is the difference? No, maybe the title is not shown here. لك يا يوسف يلا حبيبي. يلا لف على الكرسي ده. Okay? أخرت ليه يا يوسف؟ we get back to the definition of equilibrium again. If you can see, you can manage. The definition of equilibrium, and we talked about this sign. So you will get a question about this sign. It means a reversible reaction, and a definition of either equilibrium or dynamic equilibrium. The title was here, yeah, Joanna, but in the scan didn't show. Okay, so a definition of a dynamic equilibrium or equilibrium. Again, in a closed system, and the rate of forward reaction equal the rate of backward reaction, while concentration remains unchanged. In addition, the reaction never stops. Either 1 point from these 4 points in any paper 4 or paper 2.
Can you repeat the last point about the rate of concentration?
The amount of the product and the amount of the reactant stays the same, which it is called the concentration. We will practice calculation today to understand more about the concentration. Now, if you are in charge for production, for example, this ammonia, I need to get a maximum product. A maximum product called the what? Percentage yield at equilibrium. So this point, again, I repeat, our goal here in this kind of reaction, I need the reaction to go forward. I need the reaction to go forward. All right? All right, يا شباب? So, our goal, I need to control certain condition to get the product. That's our purpose. That's our goal, to get a product. All right? So we are talking now about 4 factors called what? Increasing the percentage yield at equilibrium. What's the meaning of yield? The amount of the product form. All right? Let's start. Pay attention, please, to understand it. I will write down this reaction. We will study later on last chapter manufacturing of ammonia. I will write down the equation. We will study that in more details later on. Ammonia is made from nitrogen and the hydrogen. So we get here ammonia gas. All material, they are gaseous state. So what is the factor? We'll talk about it. I will talk about the pressure. The pressure, we know from the chapter of a rate of reaction, it affects the gaseous material on. All right? So our goal again, what? I need a maximum amount of the product. After 2 arrows, ammonia in this case, NH3 is called ammonia. All right? So I will talk about the pressure. They will ask, what's the question? The effect of increasing the pressure on the percentage yield at equilibrium. The effect of increasing the pressure on the percentage yield. What you do? Very simple way. You count this value, the coefficient 3, where there is nothing, so 1. A total value here, it is 4. All right? And what we have here after the arrow? 2. Assume I have here 4 students. All right? And this student, they are kicking the wall of the container, or not the container, the wall of the class. Well, other side, I have only 2 students. All right? Which side has more pressure? 4 students or 2 students? 4, of course. And we said equilibrium. So what will happen? A reaction will go to the direction of the fewer number of moles. Exactly. But what you write down in the answer, how to write down an explanation, this is important. By rising the pressure here in this case, simple way, just count a total number. If there is no value written, it is 1. It is not 0, it is 1. Okay, well, I have 3 of hydrogen, so you add 3 plus 1, it's 4. Here I have 2. Where is the lower value? In the direction of ammonia. That is our product. So it is good idea to increase the pressure. So as a student, if you check that the material or gaseous state, that is very good, because we are sure in the pressure effect. All right? So if you have fewer number, I have here 2 students, you answered the question, Joanna. I have 2 students here. I have 4 students. We said equilibrium. What's the meaning of equilibrium? It's like a balance, like exactly equal amount. If you have here fewer number of students, as I show here, it's just to understand. So the pressure exerted by the student is less. I need to be equal because of this sign, all right? So a reaction or an equilibrium will move this direction to compensate. So what you write down in the answer to get a full mark, it will go, the percentage yield will increase. What is the yield? Ammonia. The amount of ammonia, product. The explanation, the equilibrium will go where? Where is it 2? Where is the 4? 2 is less, it will go to the less number. Clear? To the less number of mole. Under one condition, Yanada. Gaseous material. If there is solid or liquid, ignore it. We will see question together. The pressure only for the gaseous material. Listen, Yasalma. I have all this material in one container. In one container, what we do? We apply pressure. I have here this material at the beginning. We will notice that ammonia formed. We will do testing. I will talk about it, Ya Aman. I will talk about temperature, but still we have cases about the pressure. So we have testing for the material formed. We know this material is ammonia or no. If I have hydrogen, we have tested for hydrogen. We have tested for nitrogen. So we check the amount of ammonia formed. In this case, what you do as engineer, just increase the pressure. A reason, we said it's close the container. So by increasing pressure, we see more ammonia form. Explanation, it will go to the direction of fewer number of moles. Assume I have higher number of mole on the right-hand side. Let's see an example until you understand completely this fact. I have this equation, N2O4, also gaseous state, forming what? Forming 2NO2 gaseous state. Pay attention. Yalla, Joanna. What is the number on the left-hand side? 1. And here, 2. Now, this is good idea to increase the pressure?
No.
Very good. Because if we increase the pressure, where it will go? To the reactants. This is very bad. You understand it? It will go to the direction of a less number. Where is the less number, Fatima? L1 or L2? I don't need a reactant. I need always the material after 2 hours. So it is better to decrease the pressure in this case. Or at least you know the answer. What is the answer? If you increase the pressure, the percentage yield decreases. A reason. What is the reason, ya Fatima? If you increase the pressure, where it will go? The lower number of mole. Lower number of mole, it is not the product. So you stay with your raw material and they fire you. You like to be fired from the factory? No problem. Okay. Let's see third case and then ask your question. Assume I have this material H2 plus F2. I get here, ya Yusuf, 2HF. Be careful. I have here 1 1, so total 2. I have here 2. What do you think?
Coming.
Exactly, no effect. Excellent. A reason, Salma.
I'm not done.
A reason. I have what? Just write down what you see. Equal number of mole at each side.
Getting out my
Yes, yeah.
that's all.
We are talking about the pressure. May pay attention about the pressure. Important question. I repeat again, and then I will summarize that and I ask you. All right? I need to check the effect of N, very good, ya Amin, or equal number of mole at each side, very good. So what you do as a student, just count a total number of the particle available in the equation. And be sure that we are talking about gaseous material, all right? It should be always gaseous material. And always we have this sign, irreversible reactions. They will never ask this question without this sign. So here I have 2 and I have 4. If you increase the pressure, it is good decision. Why? Because the percentage yield, what's the yield? The amount of the product increases. A reason, the equilibrium will go to the fewer number of mole. وفل stop. في الcontainer closed. And it contains a reactant at the beginning. All right? Well, ammonia started to form. Type. You increase the pressure. What will happen? It will go more. So it will increase the product for me. What is your work regarding this question? Just count in number. Best. That's it. L1 with 3. With total number of reactant greater, so it will go to the product. In this case, I have a product here, ya Halia, it is 2, while a reactant 1. So decision here, if you increase the pressure, is very bad. Again, ya Fatima, it's a closed container. I have NO2, I have a little bit from I have N2O4, I have some NO2. But compare these two values. What will happen here, ya Halia, if you increase the pressure? It will go, so the percentage yield, what will happen for that? Decreases, because it will go to the direction always of fewer number. If you have equal number of mole, no need to change the pressure. A reason, simply presence of equal number of mole at both sides. All right? I will summarize this factor only pressure, then we talk about the temperature. I write down just normal equation, and you may study this way. Reactant will reversible arrow product, will reactant will reversible arrow product, will reactant will reversible arrow product. I have here, in this case, 5 with 3. I have 3 with 5, I have 3 with 3. Yalla jury. What will happen in the first case if you increase the pressure? Very good. So percentage yield will increase. A reason, as you notice, is 3, it is less than a 5. Very good. All right? Now, Minna, if I increase the pressure in equation number B, what will happen? Minna. Minna? Hello, ya Minna. Very good. In this case, more product if you increase the pressure. This 5, and this 3. What will happen? I'm talking about equation number B. What will happen if you increase the pressure? Where it will go? Where is the direction of fewer number? You miss Minna. You sleepy or you tired? Yes, to the reactant. A reason here again, it's what? A 3 is less than a 5. We check always where is the list number. Now, if I have here 3 and 3, Mr. Omar, now you join today online. What will happen, ya Omar, in this case, if you have equal number of mole? Very good, ya Amin. So what is the effect of increasing pressure? Omar? Very good, Yemen. No effect. Well, explanation important. What is the reason again? Equal number of mole at both sides. Clear? Any question, Joanna?
Fact of increase in temperature causes the
No. Just the temperature I didn't explain. If it will go to the fewer number of mole. Okay? Yes, Nat. Percentage yield and what? Part B? Part B. Now, percentage, not percentage, I'm talking about, yes, percentage yield at equilibrium. Here we have 5. 5 is greater than 3. So we said, if you increase the pressure, where it will go? Where is the fewer number? It's 3. So it will give always more reactants. That's failure. We don't need that. Where a lower number. So always, if we have lower number of the product than a reactant, that is very good. That is good example to increase a percentage product form, which it's called percentage yield. Or sometimes they ask about the position of equilibrium. What is the meaning of position? We say from left to right or from right to left. For example, let's get back to ammonia again. This question important. If they will ask about it, about the equilibrium, they will ask about this equation, because we have also its production in our cells. Last chapter in our cells, inshallah. So what is the position? Where is your right hand side? It is this one. Where is your left hand side? It is this one. From left to right. From left to right. Where is the fewer number? That is your left hand side, which has 4. Okay? Simple. Again, they may change a question. Instead of asking about the percentage yield, they will ask about the position of equilibrium. What's the meaning of position? If the reaction will go forward, it means from your left-hand side to right-hand side, or the opposite. Here, if you increase the pressure, it will go from left to right. All right? In the next case, what is the position of equilibrium? If you increase the pressure, it will go from 2 to 1. What is the position? From right to left. Excellent. And in the last case, no change. No change, even in the position of equilibrium. A question grade 10, 11, 12, same chapter exact. I'm teaching this level, same chapter, copy and paste. All right? Next factor is temperature. Next factor is temperature. Let's talk about a temperature. At temperature, what kind of reaction we have usually, Laila? We have only 2 kinds of reaction already we studied. A major kind of reaction. We just studied in the last chapter, rate of reaction. Very good. I'm asking about a temperature, effect of changing a temperature. I have exothermic reaction. What's the meaning of exo, ya Adham? Exothermic. Releases heat. It gives me energy. It's coming from exit, to remember. I will write down this reaction, SO2 plus half O2, and we have this sign, SO3. When we see delta H negative sign, what it means? Exothermic. Thank you, Yusuf. Either they write down next to the question or next to the equation, it is exo, all right? Or they give you this sign. We understand when we see this sign, we know it is exothermic. Now, we will talk, calm down, just understand the exothermic. Now, this exothermic, exactly like if you feel very hot. What you do if you feel hot? You sit in the AC or next to the heater? Very good. El heater, I will increase the temperature in this case. This is very bad. Assume you feel very hot, temperature outside it's 50, and you sit next to the heater, what will happen? Exactly. If exothermic reaction, they said this reaction, it is forward reaction. This direction also, it's called forward reaction. If it is exothermic, if you increase the temperature, the percentage yield decreases because this reaction, it doesn't need any heating. This direction is exo, so equilibrium will go to this direction. Again, maybe it's a little bit confusing. This direction is exo, the opposite, it is endo. So the percentage yield decreases. So you check if the reaction, if the forward reaction exo, or they give you this sign. If you increase the temperature, it will be very bad. Exactly. Remember that you are feeling hot. So you are looking for AC. What is the AC? Decreasing the temperature. So if you increase the temperature, it will be very bad. What will happen to the amount of the product? Decreases. A reason, because in forward reaction already it gives heat. It doesn't need any heat. Just write down one statement because forward reaction is exothermic. That's it. That is the model answer because the forward reaction is exothermic. Yeah. Exo or endo? I'm talking here about exo only. I didn't mention endo yet. Yeah. That is good. That is good. Yes, very good. Yeah. In the question, we will see that. Okay, again, you check. Again, they will give you if the equation or the reaction exo or endo. So be sure from this point, they can't ask this kind of question without giving this data. What is the meaning of exo? It gives. So exactly as I said, one person feels hot. If you give him more energy, what will happen? Failure. He will fall down. So what is the falling down of the reaction? The percentage yield decreases. The amount of the product decreases. A reason. Just write down this forward reaction X. All right? Let's see one equation يقدم now endo. Okay? If I write down this equation, copper carbonate, it will break down, gives copper oxide plus carbon dioxide. What is the endo يا شباب? Endo needs energy, or they will give you this sign. What is the sign? Positive, very good, you use. Or they write down for you, endo. What is the meaning of endo? It needs, you feel cold, so I need blanket or heater. So if you increase the temperature in this case, what will happen? Abdurrahman, you may answer. Mr. Abdurrahman, I need to hear your voice. What will happen, Abdurrahman, the percentage product if you increase the temperature for endothermic reaction? Yalla Abdurrahman, or write down in the chat room if you can. Abdurrahman?
Miss, I don't know.
You don't know. Abdurrahman, next time I need you to come over here. Okay? You come to visit me, Abdurrahman. I have my student here in my home. Could you come next time? So if it is endothermic reaction, it needs the energy. So if you increase the temperature, what we get? We get more percentage yield is formed because already it needs the heating, that's fine. So we have only now two cases only regarding temperature. If you have exothermic reaction, exo already it gives. Never increase the temperature for exothermic reaction because our goal always, I need a maximum amount of the product. If the forward reaction, you have this sign, you never increase temperature. If you increase, so percentage product decrease, which is called percentage yield. Okay, let's talk also, Yasalma, here about the position of equilibrium of exo. If you increase the temperature, this left and this right, where it will go? If you increase the temperature, This one decrease, that means it will go from right to left. Well, it is better to clarify your answer. From right to left, that means this amount, it will be less than a reactant. We still have more reactant than product. You didn't get. Again, if the forward reaction exothermic, if you increase the temperature for exothermic, it is not needed a temperature. Already it gives me energy. فif you increase the temperature, the product decreases. The product, the percentage yield decreases because a reaction will go to the opposite direction or it will go from right to left. A reason here because the forward is exo. I have here two reactions, ya Fatima. This one, this arrow, and this arrow. If this forward reaction exo, so the other arrow, it is endo. So it will go to the opposite direction. If you don't understand this point, just leave it for the moment regarding the position. But at least you have to understand that the percentage yield decreases if the forward reaction exothermic only. Well, that is 95% question in your exam. That is the question. They will not ask about your position in this case. All right? And next case, el endo. El endo, we know that it needs heating. So if you increase temperature in this case, el percentage yield will increase. All right? Because already el forward reaction, it is end. Clear, ya shabab? So we talked about the pressure and temperature. What is the next one? El concentration. What is this concentration? Concentration, it is the amount of the material. It is the amount. I will explain it in a simple way. For example, I'm getting back to this example, nitrogen plus hydrogen, it will give me ammonia. I will not count here a value written here in this equation. But assume I have twins. I have twins in one family, okay? And Muhammad, this Muhammad and this Ahmed, for example. One day, I give to Muhammad 100 dirham. So Ahmed will get angry, right? So I have to give him the same amount of money to be it. Let's see regarding concentration of a reversible reaction. If I add more material here in this side, what will happen? Very good, ya Yusuf. More product formed to compensate. More product. Again, we are talking about it. They will not tell you we increase the concentration, but the factor it's called like this. What is the question in the exam? They will ask, if we add more nitrogen or hydrogen, what will happen to the percentage yield? Increases to compensate. Now we say equilibrium. We added more in this side, so this side will increase to get equilibrium. All right, this is easy. Similarly, pressure. All right, assume you added more of this side, ya Layla, on ammonia. What will happen on the left-hand side? Exactly, to get more of the react, to compensate the side. Again, I repeat, whatever equation, I have reactant, I have product, okay? I added more of this reactant. So what will happen to this side? It will go to this direction to increase it, to be equal. Easy. Last factor, el catalyst. Let's remember this reaction profile. We did this reaction profile together. For whatever reaction, assume I have exothermic reaction, I have a reactant over here, well, product for any reaction, I connect this line. Anyone remember what's the meaning of activation energy?
The energy released.
Minimum? Very good, Yesal. Okay, let's just show. This el green or el blue curve, it is without el catalyst. Without el catalyst. Without addition of the catalyst. If I add catalyst, it will decrease the activation energy. It decreases the activation energy. This is the value of the activation energy in the first reaction without catalyst. If you add catalyst, what will happen? We get this new route with lower activation energy. That's the activation energy if you added catalyst. All right? Let's understand now the effect of adding catalyst on the percentage yield of equilibrium. This one, it is without catalyst. All right? And the red one with catalyst. All right? Now, let's understand how to explain that for the examiner to get a full mark. Okay, a reactant, by addition of catalyst, a reactant will follow this new route until we get a product. But it is reversible. So a product will follow the same route until we get a reactant. So is there any change? No change. Again, if you add catalyst for either this reactant to get a product, okay, or a product, it will break down to get a reactant again. So a reactant colloid to get a product, that is a new route. All right? And now a product break down and give again a reactant with the same amount of activation energy. So no effect of adding a catalyst on what? On the percentage yield at equilibrium. Just it makes the reaction go faster, only in this case. So no effect on the percentage yield. Let's give example from our life. Yes, assume Salma here in the first route, the blue one, you are coming to visit, to get tutorial. Assume you are coming from Khalidiyya. You come from longer route. Assume you are coming by taxi. You paid for this route, for example, 50 dirhams or 25, like 25 dirhams. All right? If you are coming by taxi. Now, if we add catalyst, what will happen? You are going with shorter road. You ask the taxi driver to go to shorter road instead of Electra Street or Zaid Street. You come from airport or whatever road, this shorter road. All right? So that is two different ways, but in the same day, you come from the shorter road and you get back from the same shorter road. We paid the same amount of money, for example, 12.5 dirham. What is the meaning of that? If you add catalyst, no effect on the percentage yield, because already it will speed up a forward and the backward reaction. A reactant will form a product and the product break down to give a reactant with the same speed. No effect of the adding catalyst until we go to grade 11. We will study that in more details. Let's revise all these factors. Just a second, usually. First question you may see regarding this chapter. It is same question almost every year. In the first point, if you get these two arrows, what it means? It is reversible reaction. 1 or 2 marks. All right? El meaning of equilibrium or dynamic equilibrium. You have 4 points, but these 2 points, it is the most important one. What is this point? A rate of forward reaction equal a rate of backward reaction. That is the forward, or that is the backward. A rate, that's mean an amount per time from the product exactly equal a rate of the backward reaction. And the concentration remains constant. Exactly, constant. Tamam? We have other 2 points. It occurs in a closed container and a reaction never stops. The meaning of dynamic, it never stops. All right? And then there is here rule, it's called Chatelier principle. It is not important, they will not ask you. But what is the meaning of this rule? They said here in this rule, if you change any factor, equilibrium will counteract this factor. It is difficult to understand this way, but the best way to understand every factor. So here in this page, we talked about the effect of the pressure. For example, I have this table. I have a carbon monoxide and hydrogen, I have methanol. All the material gases stay. Yalla ya nada. I have 2 plus 1. I have 3 particles here on this side. I have 1 only on the probe. In this case, it's good idea to increase the pressure.
To make them equilibrium, you should make this coefficient between them.
It will go where? To the fewer number of more. You compare L1 with 3. Which one is less? L1. Always check it 2 values only. It's so simple. I assume you are tired. Okay. Now, in this reaction, ya Joanna, I have hydrogen and chlorine. I have 2 in this side. I have 2 in this side. What you see?
Equal.
No change. No effect on the percentage here. All right? No, I'm talking only about the pressure. We talk about the pressure in this case, no effect. A reason, as he notes, equal number of mole at each side. We have other examples, you studied that. And maybe they give you certain color under each material. For example, pay attention. Here it is a concentration. Okay? What we have here, on the left-hand side, I have brown. It is not shown in the note? Okay, tamam. I have brown under a reactant. Well, I have colorless under a product. All right? They are talking about what? I will ask a question here. Yalla ya jury. If I add more of either material here on the left-hand side, what you see, they will not ask about the percentage yield or position. What you notice, the color, jury, the color, what you see. If you add more of iodine or OHI, I need to be equal. So what you notice here, what you see. So what is the color? I have this brown and this colorless. Where the reaction will go? This now is more. Exactly, it will go to the right. What you notice? Observation. It will be colorless. Colorless. You understand this way? It is a new trend of your exam now. They give colorful material. Left-hand side, you see brown, and this colorless. If we add more of this iodine or hydroxide on the left-hand side, what will happen? This more now. I need to be equal to compensate. So it will go to the colorless direction. All right? Now, if I add, if I add more water in this case, what you notice, what you see? If you add more water in the second case, what you see? If you add more water, I need observation. Aman Allah, I need observation. I need observation. What you see? The color, it is written here, brown on the left-hand side and the colorless on the right-hand side. If you add more of the right-hand side, it is equilibrium. Equilibrium.
They become
What you
colorless.
know? Raise your voice.
They become colorless.
Stays colorless. That's the answer, ya Omar. If you are here, I kill you. If you are here, I kill you, ya Omar. Next time, come to answer this question. Yeah. Yes, brown. This is more now. I added more of this material. Omar, pay attention, ya Omar. Omar, Habibi, pay attention. All right? So if all this material colorless, so we just added one more of this. Whatever. Okay? So they ask what you see. What you see. What you see? So reaction will go to this direction to compensate a large amount on the right-hand side.
If I will add more water.
I will repeat again. If they ask about color change, if they ask about color change, assume I will give you this reaction. I give this reaction. N2O4, it is colorless. Okay, Nada? This one is colorless. I have here this one, 2NO2, it is brown. Okay, Nada? We said if we add more material in one side, the reaction will go to the other side to compensate. All right? As exactly, now we said equilibrium. For this, it's colorless. If I add more of this one, I add here more. What the reaction will do to compensate this amount, this more than this now. And we have this sign. It should be equilibrium. So it will go to give more brown to be equal. You added more here. Where is the other side? It will go. It will increase, but here the question mainly about what you see. فcheck the color written. This one colorless and this brown. Or they may give a different other color. So only check if they say observation or what you see. All right? That is in fact a question from AS, but now they ask about it in the O-level. And we talked about el catalyst, it is mentioned here. And we have here case study, it is just AS level, if just you can read it. Our chapter, it's finished up to this page, all right? Only the effect of the catalyst, but inshallah, we will study in manufacturing of ammonia in page 2. When manufacturing of sulfuric acid, I will explain that in the last chapter of IG. So this chapter, it is so simple, okay? Just 1 page and a half. Again, I repeat a question you may see. El sign, reversible reaction, a definition of equilibrium or dynamic equilibrium for 2 to 3 marks. The effect of the pressure, just count a total number after the arrow or before the arrow. If the number of the product less, that is good, increase the pressure. That is the summary of the pressure. If it is equal, don't change, because if it is equal and you increase the pressure, the container, it should be strong, because the high pressure expensive. We need the container to be very strong. Then we talked about the temperature, only 2 cases, exo and endothermic reaction. If the forward reaction already exothermic, where is the temperature here? This endo and this exo, they will write down either a sign or they write down exo. They will help. And always we check what we have after 2 hours. That's our goal. I need a product, not a reactant. If the forward reaction exothermic, if you increase the temperature, that's very bad. Very bad.
Yeah.
It will decrease this amount, because the reaction will go, they break the amount of ammonia formed, you get back ammonia, nitrogen, and hydrogen again. This is very bad, because we said exactly like you keep this material in 1 cup, closed cup. So you have here some nitrogen and hydrogen, all right? And we'll get some ammonia. If you increase the temperature, it is exo. The ammonia immediately break down, will give more nitrogen dioxide. That is very bad. Our goal is what? The product, all right? So check always a sign or a kind of reaction. If it is endo, it is fine. So by increased temperature, because it needs temperature or energy. ولast factor اللي هو الكاتاليست, and we said the catalyst has no effect, that's it. Okay, irreversible reaction done. Study, we will do some question also about it in the past paper later on. Well, by this part, we finish this unit, a rate of reaction, energetic and equilibrium. Of course, if you didn't get any point, you will understand more when we solve past paper question, inshallah. I will do calculation now. يلا يا أدهم.
I was gonna ask you to do the function that you said you would do at the last.
Yes. Okay. what we did in the calculation last time. Calculation, there is no memorizing, just wait. We have different kind of question in our exams. روح.
I want to find out the
Okay, so last time we talked about the rules of the calculation, and we did one question, I think, into group B. We did calculation of an empirical formula. We did empirical and the molecular formula, right? Together last time.
Asper.
Okay. And we talked about the rules needed. Let's remember the rule of the calculation again. I repeat, I call this chapter mole chapter. Briefly, we need to calculate the number of moles. Let's see the rules of the calculation again. And today we will talk about how to calculate particle. So if you have solid material, a number of mole of a solid material equal what? N, mole. If I have a mass in gram, the mass of the material in gram, and I have here AR or MR. AR, it's what? Relative atomic mass, the mass of an atom. For example, if I'm talking about the magnesium, so the magnesium is 24, a higher value. That is the AR. All right? If I'm talking about the MR, it's called molar mass or formula mass. For example, if I have magnesium chloride, I'm talking about compound. It is compound. So the MR of magnesium chloride equal what? Equal 24 plus 2 times the chlorine atoms. من periodic table 35.5. So 2 times 35.5, that is the calculation of MR. That is ABC chemistry. ABC calculation. Sorry? Relative atomic mass. AR relative atomic mass. يعني if you go to the periodic table يا جوري, it is a higher value on the element. It is a higher value. Let's see the periodic table. The atomic mass, already we finished the atomic structure, right? Where is my periodic table? Over here. Okay? Now, Jury, we are talking about the magnesium. Where is the magnesium? It is over here. It is 12 or 24 AR. 24. Right? If we have one atom, if I have a compound, it means more than 2 different atoms. All right? So I add the mass of magnesium plus the mass of a 2 chlorine. How I do that? So in magnesium, it is just 1. 24 plus a 2 of a chlorine times its AR, it's over. Very good. 35.5. Okay, Shabab? You woke up, Omar? You woke up? Welcome, you mister. Pay attention. All the mass of all the element in the compound. Yani you add a mass of any element available. It may be more than 2 elements. For example, if you have this material, calcium carbonate. So you have calcium, you have carbon, you have 3 oxygen. So it is a total mass of all elements in the compound. All right? Then that is the MR. So we have one rule here about a solid. We talked about it and we practiced last time empirical and molecular form. Next rule, if you have a gaseous material, which it is much easier to find a volume of any gas in decimeter cube equal what? Equal a mole, number of mole. Maybe you will not find the data in order in the note, but that is the summary, and then we will solve the question until we finish the whole chapter. Every lesson will do one kind. I have here 24. What is this 24? It is exactly, it is molar volume. It's a constant. So to get the volume of any gas equal a number of mole times 24. But be sure that the material, it's a gas. like hydrogen, chlorine, fluorine, oxygen. It is not for a solid, right? A rule, it is there, but it is not in order in the note. Last rule, if I have solution, what is the solution? If I have sodium hydroxide, for example, or, very good, HCl. So we have this rule, equal what? CV, you apply for a job. To find the number of mole, remember, the number of mole here equal concentration times the volume, well, volume always in dc meter cube. So simple, right? So if you have certain volume in dc meter cube, you multiply by concentration, you get a number of mole of solution. We will use these rules today in what? In calculation from an equation.
بعدين
Sorry? C is the concentration. So concentration equal N over volume. What is the N? Mole. For the volume in unit is what? dc meter cube. So you get the value in mole per dc meter cube. We will practice today, but just I'm revising a rule. Last rule, where it is introduced only this year, Avogadro's constant. 100%, it's a question in your final exam, بإذن. It was not official until last year, but now it is officially in the O level. I'm teaching that for higher level. What is this rule? Very simple calculation. It is what? I have the same triangle. I need to find a number of what? Either molecule or atoms. I have a rule equal N. What is the N again? Mole. And I have here Avogadro's constant. It is very big value. Okay? It is the number of atoms in 1 mole. No problem about the definition now. Equal 6.02 times 10 to power 23. It is always given. It is always given. Don't worry. Let's practice. Let's practice because inshallah it will be question in your final exam. They should give. التيتشر عندكم بيجيبوا exam not from the past page. Who sent me questions? Weird question. Reem or not you. Anyway, okay, let's practice. Molecule or an atom, a number of molecule or an atom. This one, this rule. So a number of molecule equal N times Avogadro's constant. Let's do example. Pay attention, please. Assume I have 0.1 mole of sulfur trioxide. I will write down here to calculate a number of molecule and next question, a number of atoms. For every calculation, 2 marks, 2 marks. How I do that? A number of molecule equal what? Just N times Avogadro's constant. Very simple. Let us do that together. So what is the number of mole given? It is 0.1 multiplied by Avogadro's constant times 6.02 times 10 to power 23. What we calculated here? A number of molecule. So you may keep it like this, 0.602 times 10 to power 23. That's it. Acceptable. What we're calculating here? A particle. What's a particle? Molecule. How to find it? N times Avogadro's constant. N times Avogadro's constant. Next question for another 2 marks. How to find the atoms? It is N times Avogadro's constant times a number of atoms in the given molecule. How many atoms here? 3 plus 1. 3 plus 1, so we have 4. So times 4. So simple. To find what? A number of atoms. Let's repeat that again. I have a number of mole 0.1 times Avogadro's constant 6.02 times 10 to power 23. What we calculate? Atoms. So you check the material given. You count the total number of atoms. not AR. No AR, no MR here. I'm asking about the number of atoms in the given particle. 3 oxygen atom plus 1 sulfur atom. I have 3 oxygen plus how many atoms here in this particle, Joanna? 4, just 4 times. Okay? So to calculate the number of molecule, it is just n times Avogadro's constant. To find the atoms, n times Avogadro's constant times the number of atoms in the given part. Let's practice more. Well, I need any one of you to help me. I need to help or need help, please. I have this material, H2SO4. All right? I have a number of mole here, 0.2. 0.2. First question, I need to, will rule again in front of you. A number of molecule equal what? N times Avogadro's constant. One step, just one step. A number of mole, it is given. Well, Avogadro's constant, it is given. If it is not given in the exam, you ask about it. Nobody memorize it, please. It is given 6.02 times 10 to power 23. All right? So what we do, so simple. Number of mole, what we have, whatever the value, 0.2 mole times the constant. What we get? Molecule. El molecule. All right? So I multiply this number of mole times 6.02 times 10 to power 23. Of course, you do calculation. What we calculated, el molecule. All right? Now, I need to find a number of atoms. Yalla ya miss. Helia. How many atoms in this particle? It is the same. N.
7. 7.
What happened?
Yeah, 7.
So N times Avogadro's constant times a number of atoms in the material. How many atoms here? I have 4 oxygen plus 5 and the 2. What is the number? Times 7. Times 7. What is the 7? It is the number of atoms in this. Just count. I have 4. This 4 plus 1 plus 2. We count a total number of atoms in the material. Let's practice last question. Last question from that. Yes.
Get the number
Of atoms. Of atoms. And molecules, it's done. And molecule is so simple. N times Avogadro's constant. If you multiply by number of atoms, N, Avogadro's constant, we find the atoms. This new question for IG, new, it was AS11, but this year officially for grade 10. Inshallah, you'll get, it's simple. It is very simple. It's much easier than other questions. Practice, practice, Yajwan. There is nothing hard. Once you practice, inshallah, it will be very easy. Let's do another example. All right? I have here, for example, HNO3. Yalla ya Fatima. I have a rule. I need to calculate the molecule equal N times Avogadro's constant. How to do it? When number of mole given here, 0.3 mole. That's it. That's it. So N times Avogadro's constant, again a rule. Substitute 0.3 times 6.02 times 10 to the power 23. What we get here? Molecule. Number of molecule. Layla, I need the number of atoms in nitric acid. What we do?
Atoms 5.
One more step to be done here. I need to find the atoms in this case.
So Solly, multiply by 5.
Count, just count whatever we have. Exactly. So N times Avogadro's constant times 5. Very good. Why 6 ya Omar? Why 6 ya Omar? This is Avogadro's constant. You are talking about, yeah, very good. So N, it is given here 0.3. Avogadro's constant is given. Well, 5, it's a number of atoms in the given material. Any difficulty in this part?
No. Quite simple.
Of course, we are doing it now. You understood how to calculate a molecule and the atoms? Sure? Yes, yeah.
Like, do they tell us this to find the 6.0?
No way, no. Either they ask atom or molecule until you go to the university. All right? Clear? We go to another kind of question. Redox or extraction of metal. Come on. What time now?
15 minutes.
Redox, it needs explanation, ya jury. Redox, it needs explanation. Okay, I will do one question about calculation from an equation, and then you for 10 minutes at the end of the lesson. Okay, if you want. Okay, for the extraction of metal and the okay. Another kind of question I need to calculate. We didn't finish yet, Adam. Listen, we didn't finish yet. Okay, I have a reaction here. Pay attention, please. For example, I have this equation. Calcium carbonate react with HCl. It gives calcium chloride plus carbon dioxide plus water. Abdurrahman, you got how to calculate a number of atoms in the molecule?
Yes.
Abdurrahman? Abdurrahman, sleep.
Wake up.
Abdurrahman? Abdurrahman, I'm coming to your home at the end of the lesson, okay? Wait me. I'm coming to punish you. Abdurrahman, in half an hour I will be there.
He fell asleep.
Answer, Abdurrahman. I need your reply. Okay, what we do if you have an equation? If I need to calculate from an equation, first step to do molar ratio. What is this molar ratio?
1.
What we have here, any value next to calcium carbonate? No. So 1. What we have here? 2. Nothing. 1. 1.
I told you.
And we cancel in the equation. That is the first step to do in calculation from an equation. What calculation from an equation, it is now everywhere in any exam of chemistry for whatever grade. And they give me here, for example, 8 grams of solid calcium carbonate. We call this chapter what? Mole chapter. Mole chapter. So first step to calculate what? A number of mole. Immediately your memory, a rule to calculate a number of mole for a certain mass, it's what? Write down, Yusuf. What is the rule?
Mass over air.
Thank you, Yusuf. You didn't give him a chance to answer. Okay. الماس over الMR. الماس, thank you, Minna. So we divide the mass given over الMR. الماس, it is given. Well, MR known value from a periodic table.
MR is 100.
We find it together. Don't worry. So first step, I find what? A number of mole of calcium carbonate. Well, please show your work in the exam. So a number of mole of calcium carbonate equal M over MR. Minna, not AR, because we have a compound. If you go to the periodic table, let's check together. Just I take few minutes to understand this kind of calculation. It is so simple. Once you understand the way, it is just system. Write down to yourself. We practice. Even there is hard question, we will do it together until you get used about that. Okay, let's see how to find the MR. We practice that together.
Yeah, 36.5 times 0.2.
I'm repeating يا عمر. I need to calculate the calcium carbonate MR. The MR of this material. That is a calcium. I copy 20 or ال 40?
40.
ال 40. Very good. So I have ال 40. It is so sensitive screen. All right. So it is 40. We have here el carbon is 6 and the 12. What is the value? 12. So plus 12. El oxygen 8 and 16. 16. Very good. So 3 times 16. What we are calculating? El molar mass. El molar mass. It is 100. It is 100. If you get a total value, of course you check. Very good. Very good. We get back to the question again. I have a mass, so we substitute. I have this value 100, I have a mass 8, so number of mole 0.08 mole. All right? What I did, I calculated the number of mole of calcium carbonate. I write down over here, 0.08. I need to find the mass of calcium chloride.
Easy.
Or the volume of carbon dioxide gas. Or the concentration of HCl. They never give this kind of question in one problem. But let's practice. If I need at least to get the mass of calcium chloride, what is the mass? Same rule. It is a number of mole of calcium chloride. We have the same molar ratio, so it is the same number of mole. If it is 1 to 1, you don't need to cross multiply.
5.84 gram.
You cross multiply only if you have different molar ratio. Now, then you multiply by the MR of this required material. So, the mass of the calcium chloride equal N times the MR of the calcium chloride itself. Thank you, Amen. So, I have a number of mole here, 0.08, with calcium chloride 40 plus chlorine 35.5 times 2. You get the mass in what unit? Gram. In gram. All right? I will do only the volume of the gas and we stop in this calculation. To find the volume of gas, what I need?
48 gram.
The volume equal what? N times 24. From where is N? Same number of mole because it's the same molar ratio. So 0.08. Simply multiply by 24 to get the volume in decimeter cube.
She's searching for a
So
mass
the
of
volume
you
of
cross
carbon
multiplication
dioxide
only.
gas equal N times 24. So 0.08
Volume of
times
carbon
24
dioxide is
Fatima.
the volume of carbon dioxide.
We get the volume in decimeter. That is a calculation from an equation. I repeat again what we do. First step, molar ratio. The meaning of molar ratio, whatever written before each material. And mole chapter, what we calculate? The number of mole of a given mass. Mass over the MR, and you understand how to find the MR from the periodic table.
Its coefficient given was 2.
Sorry?
Not change the coefficient.
It's just you add the mass of calcium from the periodic table to the mass of
Once you
carbon,
find
12,
the mass,
to the
don't
mass
count
of
the
oxygen, I have
coefficient.
3.
Do not
3
count the
atoms.
coefficient
So
of the
3
mass.
times 16.
Once you find the number of
اوكي
moles.
مش هتروحوا انتوا الاثنين النهارده قاعدين اوكي so we get 100 صوتكم هنا بتشرحوا لبعض
There is a law.
انتوش
Never add
مش هتروحوا
mass
عشان تبقوا قاعزه لدول ما يتكلموش عن كده ما انتوش مروحين
cancel the coefficient.
اوكي
And you have never.
نعم قاعدين في كرسي واحد
Two
وممكن لسه يكون في كورونا وبنشرح لبعض قدامي
So the real mass is you don't
Just
have to
send
remove this.
what's قبل ماما جوية
6.5 times 0.08.
ان شاء الله يكون وراكي مقابله الشيخ زايد
What she's
Right.
searching.
She
This
said
ولا this?
this. She said if you want to find if you have this already, yes, you can substitute this, this, and this.
عمر بيقول لك ثانكس اونلاين انت جاي يا عمر وجيب عبد الرحمن السنوسي في ايدك وانت جاي
08.
Yes, once you have the
I
one,
repeat
substitute
again, pay
everyone.
attention,
One,
pay attention
two,
to it.
one,
Okay,
0.08,
everybody.
one, 0.08.
First step to
Substitute
do from
everyone.
an equation molar ratio. meaning of molar ratio, whatever value written before the material, not in the bottom. Don't touch any value here in the bottom. Just what we have here, nothing, so 1. We have 2, I have 1, 1, 1. First step. What is the given? He gave you mass of the material. I apply this rule of el mass. Okay, it's what? El mass over MR of the given compound. From where we get this value, Salma, again, from the periodic table. If you have multiple number of atoms, you multiply. I have 3 oxygen atoms, 3 times 16. Clear? You get a number of more. Where we write, ya Fatima? Under the material we calculated 4. Okay? This one, that's why we wrote a molar ratio. I have 1 to 1. That's mean we don't have any data about this material to calculate the number of mole. Sorry? 12 from a periodic table for carbon. Carbon is 12. Okay? MR. Okay, Shabab? Then we get a number of mole of calcium chloride. It is the same molar ratio, and we multiply by its MR, we get the mass. The volume of gas is much easier because it is the same number of mole, because it is 1. We apply this rule. The molar volume is 24. N times 24. يا
بس
حبيبي.
لو الاوبشن بتاع الكالسيوم كربونات كان مثلا 2
Yeah, exactly. If I need to find the number of mole of HCl, we'll get it by cross multiply next time, inshallah. That's it for today. Thank you. If you girls, if you want for stay for extraction of metal. Type, okay. If you have any question, you may ask, Shabab, or you want to go sleep. Abdurrahman, already you are not there. I'm waiting you next class, Abdurrahman, here. كنايم خالص.
طاح في
سارك
النوم.
بس مذاكر امتحان بيولوجي.
عندك بيولوجي بكره؟
معلش.
سألوه
معلش. معلش.
Everyone left.